Hi guys, welcome to my new channel Education and Masti. So today we are going to deal with new subject, that is chemistry, and we will be dealing with these four topics, that is definition of symbol, representation of symbol by John Dalton, modern symbols and rules for writing it, radicals and valencies. I will tell you a description about this in brief. And also this is the part 1, and part 2 I will bring how to create formulas and how to understand valencies and radicals and accordingly write the formulas and how important these are for making formulas. So let's start with definition of symbol. So first we need to know what is this symbol. So you might be thinking, what is this symbol? So symbol is the shorthand notation or representation of an element. What is this? Shorthand notation or representation, or we can say it's a shorthand notation or representation of an element. So what do we understand by this is that symbol is a shorthand notation or representation of an element. Okay, and what are its example? Like when we write for the symbol hydrogen, what we write for symbol? H, helium He, then lithium Li, then for gold AU, for silver AG, like this. So basically we understand that symbol is the shorthand notation or representation of an element. Now what were the representation of symbols by John Dalton? So let's understand what were the representation of symbol by John Dalton. So John Dalton, he told that these elements are being expressed by the drawings, like this drawings or these drawings. He told that these were being explained like this. Like he told that carbon was fully black like this. Then he represented it with different symbols. Like for hydrogen he made this, then for oxygen this, then for phosphorus he made this. So for different elements he made different symbols. Not like today's modern symbols, but he made different symbols. Who made this? John Dalton. So John Dalton created these picturized symbols before the modern symbols were created. So atoms of various elements were represented by these circles, and also Dalton differentiated atoms of different elements by different markings in these circles. Like group of the circles represent compound atoms. Like if there are group of circle, it is atom, like a compound. Okay, like this. So basically with the help of this circle he differentiated between each element and many more things he did. But this didn't work. Okay, this didn't worked along. So then what worked? Let's see that. Modern symbols and rules for writing it. Today what we are writing is the modern symbols. So we need to know how John Dalton's theory was removed and how modern symbols came. So this new system of modern symbols was introduced by this John Jacob Berzelius. Okay, it was represented by whom? Johns Jacob Berzelius. So after this person removed John Dalton's story, as John Dalton's story, what like circle symbol were there, and it was very much difficult to remember and draw. So therefore in this John Jacob Berzelius, he created modern symbols, and he told that we should use one or two letters from the name of the element. Like how we use today for hydrogen, we use H. Hydrogen we use what? H we use. From hydrogen H we take and use this symbol. So he only told that elements can be symbolized by using one or two letters from the name of the element. So now I am going you to tell what are the rules for writing it. So listen carefully. So the first capital letter from the name of the element should be taken as symbol. Like for example, what are the rules? Like I am taking helium. So first capital letter should be present, that is H. Okay. So for example, as I told you this one, then if two elements start with the same letter, then second letter is added to this symbol. This second letter is written in lowercase. How? Like helium. So helium is He. Now hydrogen was H. We cannot leave H and write. So for helium we have to put E. So we can put E. And one thing we need to know is that H, the first letter should be capital and second letter should always be small letter. If this will also be capital, then that is wrong. Okay. So like you also know that carbon is C, but chlorine is not C, it is Cl, and copper is not Co, it is Cu, cuprous. Okay. So understood, basically what we need to understand here is that if first letter does not work, then second letter as small we have to write. Then what are the other rules? Other rules are that symbols are also taken from the Latin name. Okay. So what are the other rules? That symbols are also taken from Latin names. What are these Latin names? So, Latin names are basically the names which are taken from the languages of Latin. So, like what is that? So, when we talk about the Latin names, like sodium. Sodium, why you think its symbol is Na? It is not randomly taken because of something. So because that sodium's this Latin name is natrium, therefore its symbol is Na. Clear? Understood what is the circle? Sodium's Latin name is natrium, and natrium, therefore the first two letters make the symbol Na. Similarly with potassium, its Latin name is kalium, symbol K, and iron, it is ferrum, Fe. So there are thousands, not thousands, there are many more examples of this Latin name. I know 11 of the examples, but you try to identify them and tell. Now let's move on to the next one, that is our radicals and valencies. We need to know about our radicals and valencies also. These are very much important. Why they are important? Because of this radicals and valency only we are able to form our formulas. Okay, therefore these are very much important. So first we need to know what is the significance of these things. So significance of radicals and valencies, that if formula we have to make any formula, then we have to use this. Importance is only this. So now what is this radical? What do you mean by this word radical? Now what is radical? See, group of atoms of different elements behaving as a single unit with positive or negative charge. So what do we get? That any element which have positive or negative charge behaving like any of the positive or negative charges, then that is called radical. Different elements behave in different units like positive or negative charges. So this behavior of those elements is known as radicals. Okay. For example, there are two types of radicals. One is basic radical and one is acidic radical. Okay, so there are two types of radical, namely basic and acidic radicals. So what these things, basic here is our plus radical, acidic is our minus radical. So for example, basic radical, let's take the example of ammonium, that is NH4 plus, and acidic, let's take CO3 2 minus. So this 2 minus is our valency and CO3 is acidic in nature. So what do we understood here? That radicals are positive or negative charges that behave as a single unit. So there are a group of atoms of different elements which behave as a single unit with a positive or negative charge in it. So they are of two types, basic and acidic radicals, as I have told you the examples also. Now let's talk about valencies, because valencies are also equally important with the radicals. So what is this valency? You might be thinking, what is this valency? So valency of an element or radical is the number of hydrogen atoms that will combine with or displace one of the element or radical. Basically, what is the modern definition? This I told was the uh, Eric, means not Eric, like it was before the valencies discovery, or before people are not knowing about this valencies, so they were using this one. Like they thought that hydrogen atom displaced this one, therefore valencies are being formed. But what is today's modern definition is the number of electron which an atom can lose, gain or share during a chemical reaction is called valency. So basically what is this valency? This valency is something which we can lose, gain or share. Main three things, 3 points we need to remember is that the number of electrons which we can share, lose or gain during a chemical reaction is called valency. So this is valency. For example, like what are the valencies? Like when we talk about Ca2 plus, this is our valency. What do we understand by 2 plus? That this calcium has lost two of the valencies. Two valence electron it has lost. Therefore, its valency is 2 plus. And if I talk about chlorine, Cl1 minus. Why it is minus? Because this chlorine has gained one of the electron. Therefore, this chlorine has minus sign. And if plus is there, then that element has lost that much of the valence electrons. And if minus is there, means it has gained that much of the valence electron. So, are you clear with this? Now, let's move to valency variable, or you can say variable valencies. What is this variable valency? Do you know? Variable valencies are like certain elements are there which exhibit more than one valency. Therefore, they are known as variable valency. So, like there are elements which exhibit more than one valencies. Like when we talk about our iron. So, iron is present two types. Here ferrous and one is ferric. So, why do we call this one iron as the variable valency? Because it has two forms, ferrous and ferric. Ferrous is Fe2 plus, whereas ferric is your Fe3 plus. Okay. So ferrous is Fe2 plus and ferric is Fe3 plus. So do you understood what is the difference here? Like ferrous is Fe2 plus and ferric is Fe3 plus. That is only called variable valency. When an element exhibit more than one valency, that is called variable valency. Similarly, it is with mercury, copper, gold and silver. Its forms are present as say argentic, cupric, ferrous, then mercuric and many more things. And for valency 3, gold, it is auric. So let's take gold. Gold, when it is written in first form, it is written as Aurus, and Aurus means it is your Au1 plus. And if it is written auric, then it is Au2 plus. So did you understood what is this variable valency? Now let's move, or I am telling you one of the reason for this variable valency, why it is there. Like an atom of an element can sometimes lose more electrons than are present in its valence shell. That is, there is a loss from the penultimate shell too. Like when we talk about valence electron, what is this valence electron? You might have read in your classes, like these are the valence electrons. These are your electrons what are present. In inner shell 2 are present and outer shell at least 8 can be present. So this is called your valence electron. So losing, sharing or gaining occurs because of these electrons. So that only, if in valence electrons anytime there can be more loss of electrons, or it can be a sharing of electrons, or it can be a gaining of electrons. Therefore we cannot tell what variable valency works where. So if we have to identify the difference between ferrous and ferric, sometimes what happens, we get confused between ferrous and ferric, and we differentiate, we are not able to differentiate between them. We write for ferrous Fe3 plus and for ferric Fe2 plus, but that is totally wrong. So how to differentiate that? And sometimes for sulfate and sulfite also we do the same thing. You know that sulfate has the formula of SO4, and sulfite, which is HITE, that is SO3. So we also get confused between it. So if an element exhibits two different valencies, then for lower valency suffix will be OUS. If lower valency is in lower valency 1 will be OUS. If in any of the variable valency OUS is written like ferrous, then that is lower valency. Okay. And if it is written IC like this one, that is higher valency, that is supreme valency. So now you got the difference. If you will get OUS somewhere, that is lower valency, and if you will get IC, then it is higher valency. Now you will be asking then for sulfate and sulfite, what we will do? Now 8, this 8 is for higher valency, and this ITE is for lower valency. Similarly, you will do with nitrate and nitrite. Nitrite as NO2, nitrate as NO3. So for 8 it is higher valency, and for ITE it is lower valency. Now I hope it is clear to you about this, what we talk about language of chemistry. So in part 2 I will bring molecular chemical formula and chemical equations and how to balance them, and many more things about how to create formulas and what necessary things we require for that, and how radicals and valency play